Let's take a look at the hardware layer for our PLC and what sort of things we need before we start getting involved in PLC tags and mapping inputs and things like that. So what we have on the screen here is a CPU, and there's a power supply to the left. We have a very varied amount of different types of I/O modules. So this is a digital input, digital output, analog input, and analog outputs. And you'll notice that they've all got their own name. And I like to put the slot numbers in the names for the I/O modules because it just makes it nice and easy to, first off, know what slot it's in without having to visit this page. And also you'll see how it ties in with the PLC tag naming convention when we go through that lesson. So a few of the things to notice straight away is when you add I/O points into your or I/O modules into your rail, that you will need to specify the I address and the Q address for inputs and outputs. And people do this in different ways. There's no right or wrong way of doing this. However, my approach is to simply put them in sequentially. And my reasoning for that is because when we go through the input mapping layer lesson, I decouple the I address and Q addresses from their respective areas in the program anyway. So we only ever use an I address once, and we only ever use a Q address once. And they're not ever used again, and it therefore does not matter what you're doing with them. Like in any project, they can change. That information can be obtained in a different way. So largely, we don't need to worry about these, and Tier Portal won't let you overlap them or anything like that. So you don't have to worry about what these numbers are so much. But if you do have a standard approach and you do have set values for different slots and things like that, there's nothing wrong with that. It's absolutely fine. But you can end up with sort of wastage in terms of gaps between I/O layers that you then can't fit anything else in. So I'm starting my digital inputs at 0 and ending at 1. And then I'm starting my digital outputs at 0 and ending at 1. And my analog inputs start at 2 because that's the next available address. And they run to 33 because of the length of the analog input card. And then same for the analog outputs, they start at 2 because that's the next available range, but they end at 9 because of the length of the analog output data that's available. So let's have a look at some of the basic properties that we have set up. So if we start with the general tab, it's just the name, the author, and any comment that you want to give the PLC. There isn't any configuration in here. This is just catalog stuff. You don't need to worry about it all too much. There are a few things for identification and maintenance that might be nice if you were to like put in the plant designation, where it is on sort of the equipment that you're working with, and any location identifier. You know, you might have more than one PLC on that plant with the same name or the same type of name, and putting a location in just helps identify later on where it's been or where it's being used. And then the installation date, which should usually be set to the first time that you added this device to a project. So this is a long time ago in the case of this video, because this project is old. But then if we come down to the interface, this is something that we will need to change on every project that you put together. So we are always going to interface with a subnet, or most likely, because you're going to talk to other devices with your PLCs. You might not, but if you are, then you will need to set a subnet for this to work with. And then the IP address, which typically you would always set. So for this one, it's set to 192.168.0.231. We're not interested in having an open subnet, so 255.255.255.0, and we're not using a router or anything like that. And we're happy for it to generate the Profinet name automatically. We don't want to set our own name. We want the Profinet name to be what the actual PLC name is. And if you need time of day synchronization, that's where you do this stuff. The operating mode, we're not an I/O device. We are not listening to another PLC at this moment in time. So this can all stay switched off. And then when it comes to advanced options, if you are sort of looking at this stuff and you need any further advice on this, then obviously drop a comment or just go and look at the help files. Just hit F1 and go and have a look at the help files in the tier portal information center, because they are pretty good at explaining what this stuff is for. And to be honest, if you're in the advanced options, there's a good chance that you already know what you're doing. But I wouldn't touch any of this stuff if you don't know what you're doing or if you don't need it, because you could change the way that the PLC is expected to work. And then if we come down to the startup. So startup, depending on what you're doing, you may want your PLC to start up and be in no restart mode, so stop. You may want it to do a warm restart, which is just to go into run, or operating mode before the power off. So if you were in off when the power went off, then you will be in off when the power comes on, as opposed to warm restart, which is it would run the PLC even if you were off before. So the default is to be in power off. And then this is an interesting one here. And there was a period of time where I'm sure that startup CPU only if compatible was the default, because it's caught me out before. That if your CPU has a different firmware version or is not identical to what is scoped in the project, your CPU will not start, and you need to fix that and download it. But I think by default it's set to even if it mismatches, as long as it can run, then it will run. In the cycle, this is an area that I always advocate setting a minimum cycle time. And the minimum cycle time that I always set is 75 milliseconds. And that is because of how PLCs talk to HMIs in Siemens. It's all asynchronous. So halfway through a scan cycle, the HMI will interrupt basically to obtain information, or the PLC to send information to the HMI. Whereas if you have a minimum cycle time, and just say your routine usually takes 50 milliseconds and you set a minimum cycle time of 75, then you have a spare 25 milliseconds in which you can accommodate all of your communication without having to introduce jitter effectively to your program. And it's not only that, it's that the asynchronous access points won't be the same for every single scan. And you can't guarantee anything involving HMI comms in terms of when that will take place. There will still be interruptions, and you don't really need to accommodate for them if you've written your code correctly. But setting a minimum cycle time seems to improve that stuff quite a lot. So yeah, I've been setting minimum cycle times of 75 for as long as I can remember, and it's always been a worthwhile thing to do, unless of course your application needs to run faster than 75 milliseconds. But I come from a process background, so most of the time 1 second cycle time would be fine. Communication load, this sort of ties in with what I've just been talking about. Cycle load due to communication, this is the maximum value that your cycle is allowed to increase by due to your communication, or how much of your cycle time, can be due to communication. And setting a minimum cycle time again helps give some room for that communication load to be there. System clock and memory, these aren't ticked by default, which I've never really understood why. But if you want to use system memory for things like first cycle and you're always high, always low, so always true, always false, you need to come in and turn this on. I recommend leaving it as 1. And the enable use of clock memory byte, if you want to use the built-in sort of timed pulses or frequency pulses, you need to turn that on as well. And I advocate turning those on because people use them all the time. And realistically, when it comes to everything else that's in here, protection and security, we touched on in the previous video for adding hardware, that that's where this stuff is set up. This is where you do your full access, your protection for access to the PLC. It's also where you can turn on put get communication from remote partners. A lot of people still use put and get, even though Siemens recommend that you don't now. You can also put global security settings for certificate management, which is more of an advanced thing. But generally speaking, the access level is what you'd be setting here. And then when it comes to, there's also PLC alarms, which I've skipped over. Central alarm management in the PLC is on by default, and that's for all your pro diag and things like that, which you need licenses for. But that needs to be turned on. It's beneficial just to leave it on, even if you're not using it. I don't really understand why it's there to be turned off. When it comes to OPC, if you're running OPC servers and things like that, they need to be activated here. It's also where you would set up any standard interfacing, and also if I come down here, where you'd put your certificate for certificated access. If you've got those security policies in place, you can change your different types of security here and stuff like that. OPC is becoming more and more sort of frequently used and available in this sort of workspace. So it could be quite likely that you come across this stuff in the future, and it lends itself to the asset orientated programming sort of approach, because all of your data is already structured in a nice sort of UDT driven structured approach. So it's quite easy to work out where your node addresses are, because everything's using the same sort of structures for each asset. So you're just changing the namespace of where that information is. And there'll be a lesson later on touching on OPC and how that stuff works. So yeah, look out for that one. And then right down the bottom, runtime licenses is an important one as well. If you are using OPC UA, you need to set the fact that you've got a license. It's only a paper license, so it doesn't actually do any checks, but it's the sort of honesty policy of, do you have a license? You have to come in here and say, yes, I do have a license, and choose your license. Same for Pro Diag. You need to come in here and choose your license. And if you're using the Energy Suite, that also needs a license as well. So there's quite a lot of information in the and configuration options for the CPU. Moving on to the I/O cards, there's generally less. You've got the same sort of general setup of comments and authors and things like that, and the catalog information. And then really what we've got is the parameters for the module, and then the parameters for the actual channels or the input channels. So this startup, comparison preset to actual module. So again, if the CPU has started up when you're in from CPU mode, then the I/O started up, or you can set it to start up CPU only if compatible, start up CPU even if mismatch. So it's the same sort of options that we had for the CPU. And then you have your input template. So if we were to say no wire supply voltage as a diagnostic, now every single channel does this as long as they are set to follow the channel template. And you can set an input delay for every single input and things like that. Coming down here is a bit more involved in terms of what you're using this for, but there's more configuration around the module, and this is what we would be changing for most applications. So this is what I was saying about the channel number from template or manual. And we covered this in the previous lesson as well, so I'm not going to go into it in all too much detail. And you have that for every single module that you add into your system. So some of the things that are less obvious and that can help with the sort of structured approach of things and the standardization of things are making use of things like system constants. So if you come and have a look at the system constants here, you can see that every module has a hardware identifier, including the CPU as well. If I swap to slot 3, that's 258. This one, slot 4, is 259. And you can't modify this. This is something that is assigned by Tier Portal. And it's also worth noting that it might be different from project to project, even if your PLC is the same PLC. Even if you've copied and pasted it from a previous project, those hardware identifiers might be different. And that's to do with the time in which they were added to the project, the other items that are in your project. It's not, you can't sort of look at a project and say, well, that's always number 259. It might not be. So that's what this name here is actually for. So looking at the CPU, because CPU has a lot more, this is things like if you wanted to pick up information from your local Profinet interface. So there's a lot of blocks for communication where it'll say, I need to know the hardware interface that I'm working with. Instead of typing the number 64 in there, you can actually reference the system constant local Profinet interface 1. And we will see as we go through some of the programming stuff later, like why system constants or why user constants as well become so beneficial for standardization later. It's a very good way if you follow a naming convention or if you have a standard approach to picking up diagnostic information. It's a very good way of ensuring that everything stays the same, even if these numbers are different. So that's where you find all the system constants. And just touching before we finish on the network view, I already have my network set up, but if I needed to connect my CPU to a HMI or to another CPU, then it's a simple case of dragging across, making your connection. One thing that is worth noting is if you're making HMI connections, you also need to make a HMI connection. So putting them on the same subnet is not good enough. You also need to then drag across a HMI connection. There are various circumstances, because you can already see this says HMI connection 2. There's already some circumstances in which TIA Portal will do that for you. If you're modifying PLCs or HMIs and making connections through the sort of data tables and stuff, it may do that for you. But strictly speaking, when you put your hardware together, I always draw these connections out then and name them and things like that at that point. And that way it just keeps it nice and easy and your hardware is set up and ready to go. So in this project right now we have one PLC, filter bed A, which is here, and we have one HMI. And the next step is to have a look at how we get information from the physical modules. So, let me select my device. So looking at getting information from slots 2 to 5 in and out of the PLC through the PLC tags. And we'll look at naming conventions and the best way of sort of setting those up and laying them out to get the easiest route to our input and output mapping layers later.